Dear children, in this video we are going to learn chapter 3, squares and square roots. Let's consider some pattern. 1 into 1 is equal to what is answer? 1 is multiplying 2 times 1 square 1. 2 into 2 is equal to 2 is multiplying 2 times 2 square, 2 2s are 4. 3 into 3 is equal to 3 is multiplying 2 times 3 square, 3 3s are 9. 4 into 4, 4 is multiplying 2 times, that is 4 square is equal to 16. 5 into 5 is equal to 5 square is equal to 25. It is called a square. Chapter 3, squares and square roots. First we are going to study only square. Afterwards we will study about the square roots. After studying the squares only we can study the square roots. When a number is multiplied by itself, the product formed is called the square of that number. When a number is multiplied by itself, 2 is multiplied by itself, that is 2 into 2 is equal to 4. 3 into 3 is equal to 9. 4 into 4 is equal to 16. 5 into 5 is equal to 25. When a number is multiplied by itself, the product formed is called the square of that number. The square of a number is obtained by raising the power 2, that is 5 square. 5 is multiplying 2 times, that is called squares. Square of 5, that is 25. Square of 4 is 16. Square of 3 is 9. Square of 2 is 4. Square of 1 is 1. 1 into 1, that is equal to 1. 2 2s are 4. 3 3s are 9. 4 4s are 16. 5 5s are 25. In general, n is a natural number and n into n is equal to n square. N square is the square of n. N square is the square of n. N is multiplying 2 times and we used to write n square. N raised to the power 2, read it as n square. N square, that is called a square. Okay, now next one, that is the first point. Here we are going to study. We are studying first point is a square of a number. When a number is multiplied by itself, the product formed is called the square of that number. Square of a number is obtained by raising the power 2. Raising the power 2, we will get the square of that number. Okay, now next one, perfect square or a square number. Perfect square or a square number. That is the second one. A perfect square, or it is called a square number. Perfect square or a square number. A number is said to be perfect square or a square number if it is the square of some natural numbers. That is, 1 is a perfect square because it is the square of 1. 4 is a perfect square because it is the square of 2. 9 is a perfect square because 9 is the square of 3. 16 is a perfect square because it is the square of 4. 25 is a perfect square because it is the square of 5. So these numbers are called perfect squares or a square number. Perfect squares or a square number. Most of the time we used to say perfect square. 1, 4, 9, 16, 25, etc. are called perfect squares. In between these numbers, many natural numbers are there, but they are not perfect squares. That is, between 1 and 4, 2 and 3 it is there. 2 and 3 are not perfect squares. First perfect square is 1. Second perfect square is 4. Third perfect square is 9. Fourth perfect square is 16. Next one is 25. Next one is 36, etc. It will go on. So these numbers are called perfect squares. A natural number is said to be a perfect square or a square number if it is the square of some natural numbers. It is called a perfect square or square number if it is the square of a natural number. If it is the square of a natural number, then we can say that that number is a perfect square. What is by a square? The product formed when a number is multiplied by itself is called a square of that number. When a number is multiplied by itself, the product formed is called the square of that number. A number is said to be perfect square or square number if it is the square of some natural numbers. If it is the square of some natural numbers. Okay, let's study the list of squares of natural numbers from 1 to 20. Number and square. I am going to write it here. Number and it's a square. Number and it's a square. Number 1. What is the square of 1? 1 square, that is 1. 2. 2 twos are 4. 3. 3 threes are 9. 4. 4 fours are 16. 5. 5 fives are 25. 6. 6 6 are 36. 7. 7 sevens are 49. 8. 8 eights are 64. 9. 9 nines are 81. 10. 10 into 10, 100. 10 tens are 100. Now 11. 11 into 11, 121. 12 into 12, 144. 13 into 13, 169. 14 into 14, 196. 15 into 15, 225. 16 into 16, 256. 17 into 17, 17 into 17, 289. 18 into 18, 296. 19 into 19, 18 into 18, 324. 324. And 19 into 19, 361. And 20 into 20, 20 square, that is 400. 20 square, 400. The square of 20 natural numbers I wrote here. Square of 1 is 1, square of 2 4, square of 3 9, square of 4 16, square of 5 25, square of 6 36, square of 7 49, square of 8 64, square of 9 81, square of 10 100, square of 11 121, square of 12 144, square of 13 169, square of 14 196, square of 15 225, square of 16 256, square of 17 289, square of 18 324, square of 19 361, and square of 20 400. So up to 20 natural numbers, up to 20 you have to remember it. Then these numbers you have to by heart it. Okay, now next one is, now we are going to study the properties of perfect squares. Perfect squares. Properties of perfect squares. Number 1. The square of an even number is always an even number. Square of an even number is always an even number. 2 square is equal to 4. 4 square is equal to 16. 6 square is equal to 36. Square of an even number. Which are the even numbers? 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. Square of these all the numbers you see. Square of an even number is always an even number only. 2 is an even number, 4 is also an even number, 4 is an even number, 16 is an even number, 6 is an even number, 36 is an even number, 8 is an even number, 64 is an even number, 10 is an even number, 100 is an even number, 12 is an even number, 144, 14, 196 even numbers, 16, 256 even numbers. So square of an even number is always an even number. And odd numbers you see. Square of an odd number is always an odd number. Square of an odd number is always an odd number. That is the first property. Square of an even number is always an even number. Square of an even number is always an even number. Square of an odd number is always an odd number. Square of an odd number is always an odd number. Okay, now next one. The second property, that is the first property. There I wrote the third point, but first property. Now the second property. All the perfect squares end with the numbers 0, 1, 4, 5, 6 or 9. All the perfect squares end with the digits 0, 1, 4, 5, 6 or 9 only. 0, 1, 4, 5, 6 or 9 only. All the perfect squares you see. 0, 1, 4, 9, 1, 4, 5, 6, 9 only. Any other number can you see? That is last digit end with the digits. All the perfect squares end with the digits 0, 1, 4, 5, 6 or 9. All the perfect squares. If the number end with the digits 2, 3, 7 or 8 is never a perfect square. If any number end with the digits 2, 3, 7 or 8 is never a perfect square. So then according to this property we can find out easily, we can identify whether a number is a perfect square or not. That is the second property. That is, we can write fourth point here. If all the perfect squares end with the digits 0, 1, 4, 5, 6 or 9. If a number end with the digits 2, 3, 7 or 8, then it is not a perfect square. If a number end with the digits 2, 3, 7 or 8, then it is not a perfect square. Third property, the number of zeros at the end of a perfect square is always even. Number of zeros at the end of a perfect square is always even. 10 square, 100. 100 square, that is 10,000. How many zeros are here? Number of zeros at the end of a perfect square is always even. Number of zeros at the end of a perfect square. This one is a perfect square. Number of zeros at the end of a perfect square is always even. Here how many zeros are there? 2 zeros are there. Here how many zeros? 4 zeros are there. 10, is it a perfect square? No, 10 is not a perfect square. 9 is a perfect square. After that 16 only. So 10 is not a perfect square. 1000, is it a perfect square? No, it is not a perfect square, because how many zeros are there? 3 zeros. That is an odd number. Then number of zeros at the end of a perfect square, always it will come an even number only. Number of zeros at the end of a perfect square is always even. Number of zeros at the end of a perfect square. Number of zeros at the end of a perfect square. At the end of a perfect square is always even. The number of zeros at the end of a perfect square is always even. That is the third property. Now the fourth property. The unit place of the square of a number can be determined if the unit place of the number is known. That is, unit place of the number is 0, then its square also will end with a 0. If the unit place of a number is 0, its square also will end with the digit 0. If the unit place of a digit is 5, its square also will end with the digit 5. That is, unit place is 5, the square also unit place 5. If the unit place is 0, square also unit place 0. Unit place of a number is 0, then the square of that number also will end with a 0. Square of that number also will end with a 0. Second one I told 5. If the unit place of a number is 5, its square also will end with a 5. Example, 5. Unit place is 5, its square also end with a 5. Unit place is 5, its square also unit place is 5. 25. 25, what is answer? 25 square, 625. Unit place is 5. Its square also unit place is 5. So next one, if a digit end with a 4 and 6, then the square, its square will end with a 6. The square will end with a 6. If a number unit place is 3 or 7, its square will end with the digits 9. That is, example we can see here, 4, 6 you see. 4, unit place of the square is 6. 6 unit place of the square is 6. 4 and 6 square unit place it will come 6. 4 and 6 again it is 4, it will come 6, and 6 also it will come 6. Then next one, 3 and 7 you see. 3 and if the number end with the digit 3 or 7, then the square also will end with the digit 9. Then that is 3, 9, 7, 9, 3, 9, 7, it will end with the 9 only. 3 or 7. If a number is end with the 7, if the unit place of a number is 3 or 7, then its square will end with the digit 9. Next one, 2 or 8. 2 and 8. If a number end with the digits 2 or 8, then its square will end with the digit 4. 2, 8. See that. Answer will get, last digit, unit place will get 4. 2 or 8. 2, 4, 8, 4. 2, 4, 8, 4 will come. Okay, now, if a number end with the digits 1 or 9, then its square will end with the digit 1. Easy only to remember. 0, 0, 5, 5 will come. 4 and 6, 6. 3 and 7, 9. 2 and 8, 4. 1 and 9, 1. How we will get that? 0 into 0, 0. 5 5s are 25. Last digit is 5. 4 4s are 16, 6. 6 6 are 36. Last digit is 6. 4 4s are 16. 6 6 are 36. Last digit, what is the last digit? 6 will come. 3 3s are 9. 7 7s are 49. What is the last digit here? 9. Here also 9. So it will come 9. 2 2s are 4. 4. 8 8s are 64. This last digit 4 it will come here. Now next one. 1 1s are 1. 9 9s are 81. This last digit 1. 1 it will. So that way easily we can find out that. Okay, now example. Tell me that 384. If we find out the square of 384, the last digit will be, what will be the last digit of the square? Here last digit is 4. So answer, last digit what will come answer? 6. So that way we can find out the unit place of the square of a number. Unit place of the square of a number. If we know the unit place of the number, unit place digit of the number. If we know the unit place digit of the number, then we can find out the unit place digit of its square. That is the fourth property. That is number 6. 0 0 1 2 3 4 5 6 7 8 9 5 5 1 and 4 and 6 6 3 and 7 9 2 and 8 4 1 and 9 1. So remember that. Number 5, the square of a number is always positive. Square of a number is always positive. Minus 5 square. Minus 5 into minus 5. Minus into minus plus 5 5s are 25. If the square of a number is always, you will get positive only. Square of a number is always positive. That is the seventh point. Square always positive. Square is always positive. Square is always positive. Square of any number, whether it is a positive number or a negative number, always it will be positive. The next one, number 6, sixth property. That is, if a number is a perfect square, its double never can be a perfect square. That is, suppose 100 is a perfect square, its a double you take 200. 200 never be a perfect square. 1 double means 2. 2 is not a perfect square. 4 double, 4 plus 4 8, it is not a perfect square. 9 plus 9 18 is not a perfect square. 16 plus 16 32 is not a perfect square. 25 plus 25 50 is not a perfect square. 36 plus 36, that is 72 is not a perfect square. Then this double 100 plus 100, 200 is not a perfect square. So double of a perfect square never be a perfect square. Double of a perfect square never be a perfect square. That is the 8th point we can write here. Double of a perfect square never be a perfect square. Never can be a perfect square. Now next property number 7. Squares follow the rules of exponents, that is a square into b square is equal to a into b the whole square. A square divided by b square is equal to a divided by b the whole square. Squares follow the laws of exponents. We have studied the laws of exponents. So a square into b square is equal to what will come answer? A into b the whole square. A square divided by b square is equal to a divided by b the whole square. That is a square into b square. Example we can write 2 square into 3 square is equal to 2 square into 3 square. 2 square, that is 2 2s are 4 into 3 square, 3 3s are 9. What is answer? 4 9s are, sorry, 2 square, 2 2s are 4, 3 square, 3 3s are 9. Then 4 into 9, 36. Then if you are using this formula, a square into b square is equal to a into b the whole square. 2 square into 3 square is equal to 2 into 3 the whole square. 2 into 3 the whole square is equal to 2 3s are 6 square. What is answer? 36. 6 square, 6 6 are 36. So this square always follows the laws of exponents, that is a square into b square is equal to a into b the whole square. Then a square divided by b square is equal to a divided by b the whole square. A divided by b the whole square. Now next one. Patterns related to perfect squares. Patterns related to perfect squares. The sum of two consecutive triangular numbers is always a perfect square. The sum of two consecutive triangular numbers. One is a triangular number. Next one is 1 2 3 is a triangular number. This one, it will come like a triangle. 1 2 3 4 5 6 is a triangular number. 6 is a triangular number. See this one, it is like a triangle. Now next one is 1 2 3 4 5 6 7 8 9 10. 10 is a triangular number. See, this way we can make it as a triangle. 10 is a triangular number. So sum of two consecutive triangular numbers is always a perfect square. 1 plus 3, what is the answer? 4. 3 plus 6, 9. 6 plus 10, that is 16. 9, 4, 9, 16. These numbers are perfect squares. So sum of two consecutive triangular numbers is always a perfect square. So here we can write triangular numbers. Triangular numbers. The next one, 11. Numbers between perfect squares. Between 1 square and 2 square, how many numbers are there? 1 square 1, after that 2 is there, 3 is there, 4. 2 square means 4. Then 2 and 3, how will you get that one? That is 2 into 1. Next one, between 2 square and 3 square, 9. 4, after that it will come 5, 6, 7, 8. Next 3 square it is 9. 1 square 1, 2, 3, 2 square 4. In between 1 square and 2 square, 2 numbers are there, 2 ones are 2. In between 2 square and 3 square, 5, 2 square means 4. Next number 5, 6, 7, 8, 3 square 9. How many numbers are there? 4. 2 into 2 is equal to 4. Now 3 square and 4 square, between 3 square and 4 square. 3 square means 9, 10, 11, 12, 13, 14, 15, 16. 4 square it is 16. How many numbers are there? 1, 2, 3, 4, 5, 6. 6 numbers are there. How will you get that? Can you say that? Yes, 2 into which number? 3. See, 2 it is common, okay, always you have to multiply it by 2, then this 1 means this first number, 2 this first number, and here 3, that is the first number. So between n square and n plus 1 square, 3 plus 1, n plus 1 square. Between n square and n plus 1 square, how many numbers will be there? 2 into n numbers will be there. 2 into n, that is 2n numbers will be there between n square and n plus 1 square. So between n square and n plus 1 square, how many numbers are there? That is between n square and n plus 1 square, how many numbers are there? 2n numbers are there. Example, just example we can write. Suppose between 6 square and 7 square, how many numbers? It is calculating, that is counting, it is not possible. 6 square, 6 are 36, 7 sevens are 49. Between that, how many numbers are there? It is not easy to count, so we will find out this way. 2 into this first number, that is 6. 6 twos are 12 numbers are there between 6 square and 7 square. So using this formula we can find out that. Okay, now next one. Sum of consecutive odd natural numbers. 1 plus 3, 4. 1 plus 3 plus 5, 9. 1 plus 3 plus 5 plus 7, 16. 1 plus 3 plus 5 plus 7 plus 9 is equal to 25. Sum of first 5 consecutive odd numbers is equal to 5 square, that is 25. Sum of first 5 consecutive odd natural numbers. 1, 3, 5, 7, 9 consecutive first 5 odd numbers. Sum of first 5 odd numbers is equal to, what is the answer? 5 square, that is equal to 25. 25 will get answer, that is the answer. Then sum of 1, 2, 3, 4. Sum of first 4 odd numbers is equal to, what is the answer? How many numbers are there? 4 odd numbers, that is equal to 4 square, it will come 16. Sum of first 3 odd numbers, 3 square, that is equal to 9. Sum of first 2 odd numbers, that is equal to 2 square, 4. Okay, now that is the 12th point. Sum of the odd numbers, that is equal to 1 plus 3 plus 5 is equal to 1, 2, 3. 3 square, that is equal to 9. Now 30, next one is, all the perfect squares can be written as the sum of two consecutive natural numbers. Consecutive, nearest natural numbers. 4 and 5, nearest natural numbers. Now 25, we can write as 12 plus 13, 25. Next one, 49 is equal to 24 plus 25. 81 we can write as 40 plus 41. Nearest natural numbers, 40 plus 41, 81. 24 plus 25, 49. These all are perfect squares. So these all the perfect squares we can write as the sum of two consecutive natural numbers. Sum of two consecutive natural numbers. Next one, 14th one is product of two consecutive odd natural numbers or even natural numbers. That is, in general we can write n minus 1 into n plus 1 is equal to, we will get answer, n square minus 1. A minus b into a plus b only. A minus b into a plus b is equal to a square minus b square. That is, suppose it is example 4 into 5, 6 will come. 4 into 6, that is equal to 5 square minus 1. 5 5s are 25 minus 1, that is 24. 4 6 are 24. 5 square 25 minus 1, 24. Then odd numbers you take. These are even numbers, two consecutive even numbers. Two consecutive odd numbers, 7 and 9. 7 and 9. That is equal to, in between that 7 and 9, what is the number? 8. So 8 square minus 1 will be right. 8 8s are 64 minus 1, that is equal to 63. We know that 7 9s are 63. So product of two consecutive odd numbers or even numbers is equal to what will get answer? The between that what is the number square minus 1 you have to subtract. In general we can write n minus 1 into n plus 1 is equal to n square minus 1. n minus 1 into n plus 1 is equal to n square minus 1. n square minus 1. Now one more is there, that is 15th point. 15th point, that is some interesting patterns given there in the textbook. That is the last one, that is 1 square is equal to 1, 11 square is equal to 121, 111 square is equal to 1, 2, 3, 2, 1, 1111 square is equal to 1, 2, 3, 4, 3, 2, 1. Can you write next one? 11,111 square. Can you write that? 2 ones are there in the middle, 2. 3 ones are there, 1, 2, 3. 3 ones are there in the middle, 3. 1, 2, 3, 4. 4 ones are there in the middle, 4. Now you know multiplying these numbers, directly we can write answer. Now here how many ones are there? 1, 2, 3, 4, 5. So you will write 1, 2, 3, 4, 5. Then 4, 3, 2, 1. That is the answer. 1, 2, 3, 4, 5, 6, 7, 8 square. 1, 2, 3, 4, 5, 6, 7, 8 square. 8 ones are there. Then what will be the answer? 1, 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 2, 1. That is the answer. So some patterns it is given there like that in your textbook. So these are the important points you have to remember from this chapter to do the first exercise. So first one is square. What is meant by a square? Square, when a number is multiplied by itself, what is the answer? What is the product? That is called the square of that number. Perfect square or a square number. A natural number is called a perfect square or a square number if it is the square of some natural numbers. Then 3 onwards we have studied the properties of natural numbers, properties of perfect squares up to 9. That is, first property is that square of an even number is always an even number. Square of an odd number is always an odd number. All the perfect squares end with the digits 0, 1, 4, 5, 6 or 9. If a number end with the digits 2, 3, 7 or 8 is never a perfect square. Number of zeros at the end of a perfect square is always even. Number of zeros at the end of a perfect square is always even. If a number end with the digit 0, its square also will end with the digit 0. If a number is end with the digit 5, then its square also will end with the digit 5. If a number end with the digits 4 or 6, then it will end with the digit 6. If a number end with the digits 3 or 7, it will end with the digit 9. If a number end with the digits 2 or 8, then it will end with the digit 4. If a number end with the digits 1 or 9, then its square also will end with the digits 1. Now, next one. Square of all the numbers, okay, square of all the numbers, squares it will be always positive. Square of any number, you take the positive number or a negative number, always it will be positive only. Double of a perfect square never be a perfect square. Double of a perfect square. Suppose you are taking 16. Double means 16 plus 16, 32. It is never a perfect square. Then next property is that squares always follows the laws of exponents. A square into b square is equal to, we can write a into b the whole square. A square divided by b square is equal to a divided by b the whole square. Now after that we have studied the patterns related to perfect squares. Some patterns are there. Triangular numbers. Sum of two consecutive triangular numbers is always a perfect square. Sum of two consecutive triangular numbers is always a perfect square. Then between n square and n plus 1 square, how many numbers are there? That is between two consecutive number square. Is between two consecutive number square. How many numbers are there? 2 into n numbers are there. Then sum of the consecutive odd numbers. Sum of the consecutive odd natural numbers is equal to. Suppose first 3 odd natural numbers, if we are adding, then we will get the answer 1, 2, 3 numbers, then 3 square 9. If 4 odd numbers we are adding, then 4 square 16 it will come. If 5 odd numbers, 5 square 25 will come answer. Then any perfect square can be written as the sum of two consecutive natural numbers. Sum of two consecutive natural numbers. 4 and 5 are two consecutive natural numbers. So this perfect square, 9 is a perfect square, can be written as the sum of two perfect square, sum of two consecutive natural numbers. The next one is n minus 1 into n plus 1 is equal to, we will get answer n square minus 1 square. That is the product of two consecutive even numbers or odd numbers. 4 into 6 is equal to product of two consecutive odd numbers or even numbers. We will get answer n square minus 1, that is 5 square minus 1. 5 square 25 minus 1 24. 6 fours are 24. That is the formula. N minus 1 into n plus 1 is equal to n square plus n square minus 1. Then 15 to 1. Some special patterns are there like that. It is very interesting. Then check your textbook, and then some more examples it is given there in your textbook. Okay, then this much you have to remember to do the first exercise. So read the textbook and write down the notes in your notebook and practice it. Next video I will start the exercise. Thank you so much.